Alright, so in this video we're going to be doing some practice with integrating power series, okay? So we are going to be given a function. Here we have the inverse tangent of x, and what we're going to do is we're going to describe this. We're going to want to describe this as a power series, okay? And to be able to do that, we're going to have to integrate some power series, and yeah. So we have like I said, we have f of x equal to the inverse tangent of x. And if we take a derivative here, you can see that f prime of x will equal, well, 1 over 1 plus x squared. Okay? Written another way, this can be written as 1 over a 1 minus negative x squared. Okay? If we write it like that way, then we can describe it as this power series here, the sum from n equals 0 to infinity of negative x squared to the nth power. Now what we can do here is if we integrate this 1 over 1 plus x squared and we integrate this power series, we end up with our power series, and of course if we integrate this, that's tangent inverse of x. So we can say the integral of 1 over 1 plus x squared dx is equal to the integral from of the sum from n equals 0 to infinity of negative x squared to the n. And dx here. Now to make this a little simpler, what we can do is say that this is negative 1 to the n, and this is something that we didn't do in the explanation video that actually probably is going to be a little helpful here. We have a negative 1 to the n, and that's going to be multiplied by a x to the 2n. There's just less stuff that you have to do afterwards to kind of simplify what's inside that sigma. Alright, this is the same thing as this. Okay, all I did was just take it apart a little bit. Now, of course, we're going to have a dx on the end here. And the integral here, that's going to be tangent inverse of x. And here, of course, we're going to start off with a c. We'll have c plus, this will be the sum from n equals 0 to infinity of, and now we need to see what's going to be on the inside. Well, we're going to have a negative 1 to the n. That's a constant, that's going to stay, okay? And, well, x to the 2n. Well, that's going to be x to the, we're going to add 1 to the exponent, 2n plus 1, and we're going to put that on top of the new exponent, which is 2n plus 1. If we plug in a value for x, we're going to be able to solve for c here. Okay? It's going to make our lives really easy if we just choose 0. Okay? We can choose anything, but 0 is going to make our lives easy. We get tangent inverse of 0 is going to equal to c plus the sum from n equals 0 to infinity of negative 1 to the n times a 0 to the 2n plus 1 over 2n plus 1. You can see here that this summation will go to 0. This series is going to go to 0. And tangent inverse of 0, that's 0. So you're going to get this c equals 0. So writing this series out up here, what we're going to get is that the tangent inverse of x is equal to the sum from n equals 0 to infinity of negative 1 to the n times x to the 2n plus 1 over 2n plus 1. And there is your power series. So all we had to do here was just integrate a power series, okay, in order to get the power series that we were looking for that describes tangent inverse of x, okay? So now what if we wanted to find the radius of convergence here? Okay, what if we wanted to find the radius of convergence for this? Well, we could just, instead of doing a ratio test with this final power series here, we're integrating. So our radius of convergence is not going to change, okay, with this negative, with this power series here. Okay, it's not going to change from this power series to this power series. So what's the radius of convergence for this power series? Well, we know here that the absolute value of negative x squared needs to be less than 1 for this thing to be convergent. Okay, cool. Well, if we use our absolute value here, we get x squared is less than 1, which means that the absolute value of x needs to be less than 1, which also means that x is greater than negative 1 and less than 1. So there's your interval. Okay, here's your interval, which means, well, the radius of this, okay, from negative 1 to 1, half of your interval is 1. So r equals 1. Okay? I'll draw that picture again for those of you who like the picture. Okay, our interval is from negative 1 to 1. The center of our interval is 0. So from the center of our interval to 1, that's 1. Okay, this is 1. Right, that's kind of from the center to the outside, that's your radius. So here's your radius of convergence from the center to the outside. Okay, so there you go. That's going to do it for our first problem. So here we have our next problem, f of x equals natural log of 5 minus x. So let's express this as a power series. First step, take a derivative. Okay, we take a derivative here, and we're going to get negative 1, because we have to do the chain rule, over 5 minus x. Okay, now we want to get this close to, 1 over 1 minus something. So what we can do here, take out that negative. We kind of have a negative 1 sitting on the outside here. And, well, let's just kind of see what we have already. We have a 1 over 5 minus x. And we want a 1 here instead of a 5, so what we're going to do is take out a 5, and that gives us negative 1/5 times 1 over 1 minus x over 5. Okay, here is your common ratio. Okay, so that's what's going to go in this power series here. The sum from n equals 0 to infinity of just x over 5 to the n. Okay, so, and of course, sorry, this is not equal yet. We need a negative 1/5 out front. Okay, because this negative 1/5 is also just going to come over here. Now, to get back to this natural log of 5 minus x, we need to integrate this. We need to integrate this piece right here. So we take the integral of negative 1 over 5 minus x dx and set that equal to the integral, actually we could say negative 1/5, the integral of the sum from n equals 0 to infinity of, I'm going to rewrite this just to make this a little bit easier for us. This will be a 1/5 to the n times x to the n. Okay, and we're going to have a dx here. Okay, always remember we're integrating with respect to x and not n. That's a big thing. In doing our integration step, we will get natural log of 5 minus x is equal to c, right, our constant c, minus 1/5 the sum from n equals 0 to infinity of, well, the integral of the inside here, that's going to be still a 1/5 to the n, okay? But now we're going to have a x to the n plus 1 over n plus 1. All right, so let's figure out what c is. All right, let's use x equals 0. All right, plug in x equals 0. When we plug in x equals 0, we're going to get that the natural log of 5, right, 5 minus 0, 5, equals c minus 1/5 the sum from n equals 0 to infinity of a, well, we can write this as 5 to the n in the denominator, okay, just to make our lives a little easier, but you can already see here that this whole summation is going to go to 0 because we have a 0 to the n plus 1. Be 5 to the n times n plus 1. All right, so you can see that this is going to become 0, and that c is going to equal something that's not 0 finally. It's going to equal natural log of 5. So what you're going to get, if I give myself a little bit of room here, get that out of there, we get that natural log of 5 minus x equals natural log of 5 minus 1/5 the sum from n equals 0 to infinity of, now we have an x to the n plus 1 over a 5 to the n times an n plus 1. Now you can make this look a little nicer because you have a negative 1/5 out here and you have a 5 on the inside as well. Okay, so here's what we're going to do. Okay, give myself a little bit more room here. We're going to do the natural log of 5 minus x is equal to the natural log of 5 minus the sum from n equals 0 to infinity of x to the n plus 1 over, all right, watch what I do here. We have 5 times 5 to the n, that's going to be 5 to the n plus 1. And then that's going to be times n plus 1. Now see how everything is n plus 1 here? All right, that's kind of dumb. That's just writing a bunch of n plus 1. When we could be writing a bunch of n's, all we have to do is raise the index by 1. Okay, natural log of 5 minus x equals natural log of 5 minus the sum from n equals 1 to infinity. Okay, that's n equals 1, not n equals 0. And since we raise the index by 1, we have to lower the n's by 1, so we get x to the n over, I'll write this one first, n times 5 to the n. And that is a better looking power series. Okay, so there you go. There's your power series. Now what is your, let's do your radius of convergence here. Okay, well, what do we have here? We had the sum from n equals 0 to infinity of x over 5 to the n, which means that we're going to have x over 5 is less than 1 and greater than negative 1. So you know that your interval is from negative 5 to 5, okay? Which means that your radius is 5. So yeah, that's it. So we just took a derivative to start off with, and then to get back to the function that we originally started off with, okay? To get back to that natural log of 5 minus x, now with the power series, okay, we had to integrate. We integrated this, we integrated this, okay? Now after doing that, we got back to our natural log of 5 minus x. We cleaned up the power series. That's kind of going to be something that's a little tedious that you have to do anyway. We clean up that power series, we get this, and then we look for our radius and interval of convergence, okay? So that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series, the explanation video for integrating power series, and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.